Phosphorus pentachloride decomposes according to this formula, and we have some number of moles is injected into a 4-liter container at some temperature. Okay, so we need to calculate the concentrations at equilibrium. So we know that Kc is. So what we need to do is Kc equals the concentration of PCl3 times the concentration of Cl2 all over the concentration of PCl5. Okay? And we know that the equilibrium is 1.8, so we need to figure out what to put in here. So we need an ice table. Okay, so ICE, and we have the equation PCl5, PCl3, Cl2. And they tell us that we start with 0.305 moles of this. Okay, but what we need to keep in mind is 0.305 is the number of moles, and that is in 4.1 liters, so the concentration is 0.0744. Okay, so I want to use concentrations. It's going to make my life easier at the end. Okay. Do I know how much has changed? No. That's called x. So since the coefficients here is the same as here as is here, the amount of x that's reduced is the amount of x that we get, and the amount of x we get for chlorine. So at equilibrium, with 0.0744 minus x, this is x, this is x. So if I take these numbers, okay, or expressions, I can plug them in. I get x times x over 0.0744 minus x. So I'm going to multiply 1.8 times 0.0744 minus x, and I get 0.1339 minus 1.8x, and that's going to equal x squared. I'm going to rearrange, so I get x squared plus 1.8x minus 0.1339 equals 0. And then I can use the quadratic equation, and I am going to use the quadratic calculator. Okay, so this is math.com, and it's a quadratic equation calculator. I put my numbers in. I got a negative number. Can't get a negative concentration, so I'm going to use my positive number, okay, of 0.0715, and that is my concentration of x. So x equals 0.0715. So I know my concentration for chlorine and PCl3. I need to find PCl5. So it's 0.0744 minus 0.0715, and it's 9 and 200. Okay, so I have this concentration and this concentration.